So my name is Tony Krishock. I am the Vice President of the Central New York Humanist Group. This little project of mine here has been going on, I don't know, since about February. I blame this entire debacle that's about to unfold before your eyes today. I blame entirely on Richard Zalewski. Richard and I were having a conversation in one of our meetings, and Richard said, well, we should put together some presentations about like the history of humanism and like, so instructional things that we can help people understand what humanism is. And I said, yeah, sure, that sounds like a great idea. Boy, was that a mistake. It turns out that humanism is wide and deep. And the more you look into it, the more complex it gets. So let me, I'll leave it there for a moment. Let me talk a little bit about my motivations. One of the motivations was I thought Richard had a good idea. So I started looking into the history of humanism and about what it means. And I've always had a question or several questions in my mind about, when I decided that I was a humanist back 2016 roughly was when I joined the group. I said, okay, I'm a humanist. What does that mean exactly? I mean, we have kind of a canned statement about, well, we're non-theistic and we believe in humanism and secular values and reason and science and all that stuff. All well and good. But that's a hard thing to explain exactly. And I wanted to look a little bit more into what it means to be a humanist and what our roots are. That was another big motivation too. We talk about humanism as if everyone knows what it is. But so often I get the, okay, well, what is humanism? It's a hard question to respond to. So I wanted to look more into our roots. I mean, you think about, Judaism can point to deep roots, right? They can point to what they believe and they can tell you exactly about the Talmud and they can quote it and they can tell you everything you want to know about it. Catholics can do the same thing. They can tell you about popes and they can tell you about crusades if they ever want to talk about that. They tell you about, the various things that Catholics believe. It's hard for us to point to the influencers in our movement. Who are they? What did they do? So I started looking into this a little more deeply. So the question is, who are we exactly? Who are our founders? Who are the people who influenced our movement? How did humanistic thought evolve? I mean, we didn't just decide, hey, we're going to be non-theistic, we're going to believe in reason and science and secular values. There had to be an evolution there. We didn't just decide that. Specifically, what role did astronomy play in it? Now, this is, I admit, this is my attempt to kind of narrow down the focus of humanism. The more you look into humanism, you get into the Renaissance, you get into the scientific revolution, you talk about music and art, culture and language. And there's so many things that make up the Renaissance that it's almost impossible. You certainly can't put it on a PowerPoint slide. There's just too much. So I thought, well, why don't I just talk about astronomy? Astronomy is a thing that I know something about. I also happen to be the president of the Syracuse Astronomical Society, and I've been an astronomer since I was a kid. And I've always had the feeling that astronomy is where a lot of humanistic thought evolved. Astronomy is the oldest science. And it's something that everybody can look at. I mean, everyone's been looking at the night sky. We all look at the same stars, and there's a long history of human beings trying to explain nature by looking at the stars. I mean, from the standpoint of navigation, astronomy was critical. People had to understand where they were in relation to the stars. That's how you navigated. You used a sextant to make measurements, calculate angles from positions of stars and planets. That's how you knew where you were. When human beings settled down after being basically wanderers, when we started settling down and doing agriculture, we wanted to know when to plant our fields, when to harvest, and we used the stars to do that. I mean, for instance, when you saw Vega, the brightest star in the constellation Lyra, start to rise in the sort of middle to late spring, that's when you knew it was time to start preparing your fields for planting. And that's a thing that you can, that's something that happens the same time every year. So that's how early human beings learned how to use astronomy to help them survive. So during the 14th century, there was a cultural movement called humanism. It gained some momentum in Italy, in the area that's Florence now. Heather took a vacation to Florence, Italy, not long ago, and I am green with envy. I sure hope that she brought pictures and can give us a talk about that someday. I'll go ahead and throw you on the hook. That's a wonderful vacation I'd like to learn more about. Anyway, among its principles, humanism promoted the idea that man was the center of his own universe, and that people should embrace human achievements in education, art, literature, and science. The 14th century, by the way, is many centuries ahead from where I'm going to be talking, but I just wanted to give you some rough idea. This is going to be a multi-part presentation. Thanks, Richard. During this period, most humanists called themselves Christians. So the concern was to purify and renew Christianity and not do away with it. Their vision was to return humanism to the sources, this ad fonte idea, which was to look a little deeper than just the scripture and try to find meaning in nature to reinforce Christian doctrine. So that there was not, they had to get past sort of medieval thinking and try to put Christianity on a more firm foundation. The Catholic Church really supported humanistic efforts early on. They've learned better now. So let's talk a little bit more about the specific connection between religion and astronomy. Astronomy and religion have been closely intertwined, particularly during the early history of astronomy. I mentioned the time when we stopped being hunters and we started settling down, farming the land. Astronomy was really critical for timing the things that human beings needed to do. Celestial bodies were the subject of worship back then in the Stone and Bronze Ages, not surprisingly. In many ancient religions, the northern circumpolar stars are associated with darkness, death, and underworld of the dead. I find that kind of interesting. The circumpolar constellations are basically Ursa Major, the Big Dipper, Cassiopeia, Cephus, those constellations. They don't look particularly threatening to me from an astronomy standpoint. I don't know how you get there exactly, but they were apparently scared to death of these constellations.
Were they the same constellations back then, or did they have different set of constellations?
The constellations that we currently have right now, especially the ones along the zodiac, the 12 constellations are about 30 degrees wide. That's a gift of the Babylonians. They gave us that, and we still have it today. I mean, you pick up any newspaper. The moon is in, whatever constellation. We still talk in that way. As I mentioned before, as agriculture started to develop, we needed to be able to keep accurate time, which led to more careful tracking of the position of the sun, moon, and the planets. So let's talk a little bit more about this pre-classical astronomy. Specifically, let's start with the Assyrians, for the first, some of the earliest records of astronomical observation that we have. Assyrian astrologers tried to predict the future by studying the stars, this idea of divining the will of the gods. The Assyrian kings employed astrologers to help them predict the future. There's a lot of stories about, like, if you try to predict the future, there's two ways your prediction can go. You're either right or you're wrong. And the Assyrians burned through a lot of astrology. Yeah, exactly. In 660 BCE, the Assyrian astrologers recorded the earliest known description of the solar system. So the Assyrians became aware that there were some stars that weren't really stars. When you look up into the night sky, you see the stars, but you also see objects that don't quite look like they should be stars. They're bigger and they're brighter and they're steadier. They don't blink or twinkle or anything like that. Those are planets. And the Assyrians recognized pretty early. I mean, those are obviously different than all the other stars that we see, and they move differently. I mean, you can track them from night to night. They move in a direction. The stars don't seem to move in that way. They move differently. There's some biblical references to auroras, and most notably Ezekiel 1 and Isaiah 34 or whatever that is. I don't do much with the Bible. But there's also an interesting reference to Orion in the Bible, particularly the belt stars of Orion. It was typically viewed as a time of great danger when you looked toward the west and you saw Orion's belt stars were almost level. There's some stories in the Bible about the position of Orion and specifically the orientation of Orion's belt. That time being associated with unrest or civil disturbance. It's kind of interesting.
The same time every year.
Well, I mean, Orion's in that same position every year, so yeah, I would presume so.
Bible came from the Middle East, so you know,
Right.
if you were there, and you know, I'd be interested. I gotta go
Right.
look and see what the weather, you know, things about the weather or
Yeah.
something.
The Sumerians are the next record that we have. They were the first astronomers were the Sumerians, who mapped the stars onto a set of constellations. So many of which survived in the current zodiac, which we still use, and they were recognized all the way through ancient Greece. So the constellations, the names of them, and the shapes of them are entirely the fault of the Sumerians. They you know, when you look up and you say, yeah, it's a goat, I'm not seeing a goat. That's the Sumerians. Mesopotamian astronomers were able to follow the motion of the stars, the planets, and the moon, so much more carefully. They started making measurements. That's the big thing. They weren't necessarily asking the question why. They were making measurements specifically. So they would measure, for instance, you know, Arcturus is 23 degrees above the northwest horizon at for a particular time in a particular month, with the phase of the moon being what it is. In other words, they recorded enough data about the position of stars that we can trace back, and we can know the exact moment of when they made those observations. The Sumerians were very good at just recording data and just making accurate measurements.
What language do they write, or what alphabet do they write in?
Would have been there, pictographic.
Yeah, I would imagine something of that nature. That's a good question. I don't know what language they would have used.
Especially their numbers.
Yeah,
Or Arabic.
yeah. I would imagine it would be some form of Arabic or Persian, perhaps. That's a good question.
But I think that they were extinct by the time.
Yeah,
You know, Arabic letters came into existence. You know,
Right.
yeah, they tell them.
They got their own. Oldest language we can read that's come to us from antiquity, clay tablets surviving from as far back as roughly 3200 BC. So that's neat.
Did these early people think that we were the center of all this universe, like the Christians thought?
that was a prevailing presumption. It was assumed that we were the center of the universe. And why wouldn't you? That's kind of a tempting thing. That's kind of a tempting conclusion to come to. I mean, when you step outside into a field and you look, you don't perceive your own motion. In other words, you don't perceive the Earth is moving, but you do easily perceive that objects are moving. You can trace the positions of, you can watch stars move, and you can see that they're in different positions month after month and as the years go by. So you perceive that you're stationary and everything else is moving. That's basically the geocentric idea, that you're the center of everything.
And I don't know if it's kind of a little bit of a rabbit hole, but do they have enough ability to do time, like, you know, time of day, to be able, like, were they using hourglasses, or do they have, you know, time to sort of be able to track?
The next statement is that by studying the phases of the moon, they came up with their first calendar, which is basically a simple time piece, right? I think gradually they did start developing the concept of time, but the data that they recorded about the positions of objects was accurate enough where we can tell what time they made the measurement. So by recording the data the way that they did, they actually created the concept of time, the idea that things create one after the other. Ancient Sumerian astronomers created the first star charts, which is kind of close to my heart. When I started in astronomy, I made my own star charts, and I didn't realize that I was, you know, following in good footsteps here. So that's the first. That's what the first star chart looked like. I don't know how to read it, but yeah. Well, moving on now to the Babylonians and their contributions. The Babylonians were the first to recognize that astronomical phenomena are periodic, and they applied some pretty complex mathematics to describing their positions. They used math to make predictions, which is also kind of a step towards science and reason. That's a kind of a concept. The Babylonian astronomers developed the signs of the zodiac. I'm going to butcher a lot of these names. I'm just warning you guys now. They are made up of they divided the sky into basically 12 to 3 sets of 30 degrees each, and the constellations that inhabited each sector. So if you look, pick a direction east, there's a constellation along the zodiac, and it's 30 degrees from there is another constellation, 30 degrees from there is another constellation. That's a pattern that we still stick with today. I mean, we talk about the constellations of the zodiac today. The Babylonians believed that the universe was divided into 6 levels and 3 heavens. So they couldn't quite get away from this idea of associating the stars with gods. This is an ancient ideas. This is an ancient idea. And the Babylonians were just one of many the civilization that did this. The planets of our solar system, which were believed to be the brightest stars in the night sky, were the most important to them. So they assumed that the planets weren't planets, that they were stars. They treated them like stars, but they understood that the motion of the planets, as we understand them, is quite a bit different. The particular devotion was given to the movements of Jupiter, which they identified with their god Marduk, and Venus, which they associated with Ishtar, the goddess of war and love. But they didn't know that they were planets. They assumed that they were just particularly bright stars. The movements of the planets were perceived as omens, and they used to predict many important things such as crop failures and war. Now again, a prediction is 50-50, right? If you're saying, well, Jupiter's in the east and Saturn's in the west, therefore we should prepare for war or plant some crops. 50-50, you're going to be right. Early Babylonian astronomy would have a huge influence on later Greek thought. The Babylonians made some incredibly careful measurements, and their data survives today. We can trace back what they were looking at based on their data. That's the real gift, and it's a gift that would haunt the Greeks. In classical Greece, astronomy was a branch of mathematics. It was used to simulate geometric models and to simulate celestial motion. Pythagoras was a big contributor. He was mainly more interested in mathematics than he was in astronomy, but Pythagoras produced many of the mathematicians in later Greece who would make all of the contributions that they made. He produced a lot of very good students. Astronomy was considered to be one of the 4 pillars in Greek society, along with math, basically geometry and music, arithmetic, basically geometry and music. Plato created this 2-sphere idea of planetary motion, which is a geocentric model. It places the Earth at the center of the universe and every other planet. And I don't know how he concluded the order of the planets, but that was a big source of debate in ancient Greece. Nobody quite knew, for instance, what to do with the moon, whether it was supposed to be close or further away. Astronomers today still use this idea of spherical astronomy to describe the apparent positions of celestial objects on the celestial sphere. And this is something that I do in the Astronomical Society when we're out in the field. Spherical astronomy just refers to what the sky looks like to you, the apparent positions of the sky. So for instance, we talk about the meridian, which is the line from north to south going directly above your head. We talk about things to the east of the meridian and to the west of the meridian. We use the same kind of language that the Greeks used to describe that. You can talk about all of the planets you can talk about elongations and conjunctions, closest approach and furthest approach away. These are concepts that the Greeks used in their descriptions, and we've adopted that. That's part of our language of astronomy today.
Did they have any clue as to distance, or
We're getting there. Eudoxus, which was another of Plato's students, created this idea of a system of concentric spheres, and they assigned basically one sphere to each object: the moon, sun, and the known planets. So he kind of formalized this idea. This is the first attempt at a mathematical description of the motions of the planets. Now, this is new. No culture or civilization prior to the Greeks had tried to create a model of how they thought the universe worked. The Greeks were the first to try to do this. They started with this presumption that the Earth was at the center, and they basically created spheres around for each planet. The last sphere contained all of their visible stars. They didn't know what to do with the stars, so they just threw them all into one sphere and said, let's just think of it that way. You think of it, kind of makes sense to think of it that way, right? Just based on the appearance of the night sky. Aristotle later expanded Eudoxus's model to 55 concentric spheres. That never caught on. The mathematicians had issues with that, and they just, no, that's too much to keep track of. The model had some issues. One issue was that despite how hard they tried, they could not explain retrograde motion. Retrograde motion is this fun thing that Mars does. Every planet actually does it, but you can see it most clearly with Mars because it's closest to us. The planet will be traveling along happily from west to east, and every night it'll appear a little bit further west, a little bit further west, and then it'll slow down. And then it'll start going the other direction, east. And then it'll start going west again. And you look at that and you go, how is that possible? Well, it turns out you're measuring the position of the planet based on the pattern of stars behind it, right? So you're seeing the Mars move against the background of the stars. But what you're really seeing aren't necessarily Mars isn't doing anything. Your relationship on Earth and from Mars is changing. So Mars is moving through its orbit and you're moving through yours. Mars is moving slower than you are, right? You're moving faster. So your observation point against the background stars changes briefly. And when you swing around the side and you start coming the other way, that's what creates the back and forth. But that didn't occur to the Greeks. Their model couldn't explain that. Now, they presumed circular orbits for the planets. And the reason, this is kind of the fault of Plato. Right? He created this idea of perfect geometric shapes. And he kind of pushed that. It became sort of Greek doctrine, if you will. And when it came time to decide what the orbits looked like, they immediately assumed, oh, it must be perfect. They must be spheres. But if they had talked to the mathematicians in the room next door, the mathematicians would say, well, a circle is just a special case of an ellipse. So why don't we just call it an ellipse? They'd have nailed it, but they didn't. So they stepped with this idea of perfection. If a planet is a circle centered on the Earth, the planet should always be the same brightness, which makes sense. I mean, if the planet is a certain brightness, and brightness is a function of distance, and they kind of understood that it was, then you would expect the planet to be always the same brightness all the time. It's not.
Do they have a way of measuring brightness except for just subjective?
They measured brightness essentially by comparison, right? So they knew how bright the full moon was. And they said, well, that star looks pretty bright, but it's not nearly as bright as a full moon. So let's call it 10% the brightness of the full moon, which is actually kind of a reasonable way to measure brightness. Brightnesses are usually compared back and forth. So what is the solution to your circles not working? Well, obviously, more circles. I'm kind of reminded of Christopher Walken's bit from Saturday Night Live, more cowbell. You know? It's kind of, they just decided to throw circles at it until it made sense. And really, the adding of epicycles kind of makes sense if you think about it. If you think of a circular orbit, and you let the planet have its own circle, then it's kind of going like this around, you know, and that gives you, well, okay, in some instances this is going to be further away, in other instances it's going to be closer, which would account for the difference in brightnesses. But Jupiter doesn't vary in brightness over the course of a month, right? It varies in brightness over the course of several months. So that means your circle's got to be really big, right? Otherwise the period is not going to be right. It was a valiant attempt, but I think all they did was just make a bloody mess out of a theory that didn't quite work from the beginning, but they stuck with it. Aristarchus of Samos, another mathematician and astronomer in ancient Greece, he made the mistake of saying out loud, "Hey guys, why don't we just assume the sun's the center of the solar system and go from there?" And everyone went, "Boo!" His idea didn't catch on until much later, but he let it out. It was out there, so people started thinking about it. The first known or recorded conflict between religion and astronomy occurred with a guy named Anaxagoras around 500 BC. Well, he also made the mistake of saying out loud that he thought the sun was just a great burning stone rather than a god. The Greeks had always assumed that it was a god, Helios. He was accused of offending the gods, and he recanted. So, you know, this is the first time that religion interfered with the idea of just learning. So Claudius Ptolemy, not last but certainly not least, wrote his book Amalgast, which survives to this day. It was probably the most important written treatise on the motion of the stars and the planets that the Greeks produced. And Ptolemy referenced just about every mathematician and astronomer that came before him. Ptolemy advocated this geocentric model, which we know is wrong, but his work remained the most important work to come out of early Greece. It survives today, but it survives in a form that we think it's not complete. A lot of the sections of this of his work were translated either by Muslims or by I think Egyptian translations. The translations were not good; they were not accurate. We have enough to kind of get a gist of what he's trying to say, but his book, if it had survived, would have informed every effort in astronomy for the next 2,000 years. It remained influential right up until the time of Copernicus. So, I mean, up to Copernicus, people were still strongly in favor of this geocentric model, not because of the apparent, you know, you step outside and everything looks like it's revolving around you. They believed it because Ptolemy made it clear, and his works made it very clear. The only portions of it survived into the Renaissance, and the portions that survived were sort of weakly translated and almost dumbed down to the point where they could be communicated to just about anyone. So what were the Greek contributions here? Greek astronomers and mathematicians set a foundation of scientific thinking that would turn into the scientific revolution. The Greeks were the first to try to understand the relationship between data and theory, which is fundamental to science. You come up with some idea about how you think things work and you test it. I don't know how many times I've read in a lot of the source material that I've looked at that the Greeks would produce some theory, they would make an adjustment, and then they would go out and use that theory to try to predict where planets would end up. And they'd be wrong. You know, they would look back at the Babylonian data because that was the cleanest data set that they had. And they would see that they're wrong and they'd make adjustments. This attempt to make theory fit data, that's science. That's fundamentally science. And the Greeks originated this idea. They established several concepts that would be the basis of modern science. Make observations, design a theory around it, test your theory. If the test fails, go back to the drawing board over and over and over again. The Greeks ultimately failed, but they produced a system that we still use today. That's a huge contribution. No society would match the scientific output of ancient Greece until the Enlightenment came along. Now, there were other great contributions. There was a lot of work going on in the Muslim world that's worthy of its own presentation. There was a lot going on in Egypt. There was a lot going on in China. All of them made meaningful contributions to the scientific understanding of the cosmos. I'm going to pause the presentation there and ask you guys to wait until I finish part 2, which will talk a little bit more about the decline of ancient Greece and what happened to a lot of that information and what still survives. That's it. Wow, thank you. A little too much of an overview, but I'll try to get more detail. Any questions?
Were did the early civilizations basically, let's say, where are the constellations that people recognize is the word that they use today?
Right.
Are they the same ones that were used in the distant past? I mean, obviously, how far back?
The constellations of the zodiac, which essentially traces out the path that the planets follow. That's a gift of the Babylonian Empire. They created that. They divided up, 360-degree sky into 12 30-degree wide sections. And in each section, they defined a constellation. So Capricornus, for instance, occupies a particular location in the east, and then Aquarius, and then Aries, and then, all of these constellations of the zodiac. The Babylonians are probably responsible for the reason why people always get astronomy and astrology confused. Okay, astrology deals with the zodiac, astronomy deals with what's really up there. Is that a satisfying answer?
Yeah, but I mean, for example, Cygnus looks sort of like a swan.
Right.
Okay. So I can understand that, but it still doesn't look like an eagle. I mean,
Yeah,
so-
there's some constellations that really do resemble what they're supposed to. I mean, look, if you see Ursa Major, the Great Bear, if you see it under dark skies, it looks like a bear. You can see a head, you can see paws, you can see a tail, obviously the tail of the Big Dipper. But if you look at it from a city nightscape, all you're going to see is a Big Dipper, if you're lucky. You're not going to see a bear. So you're going to look at that constellation and you're going to go, I don't see a bear. But in ancient Greece, they did not have the problem of light pollution that we struggle with today. So I'll bet the constellations looked a lot more like what they thought they were supposed to be.
Yeah, but would it go out even in really dark sky if it looked like an eagle?
It can if you want it to be. It can.
No,
You
I'm
can make
just
your own
wondering how
constellations.
far back those assignments.
Well, the zodiac constellations come from Babylon, but all the other constellations, like the ones you're referring to, Cygnus and Lyra and all the other ones, those are more modern creations. They came about from the International Astronomical Union. The IAU has designated 88 constellations that are recognized internationally. And some of those constellations were defined in the Islamic world. Some of them were defined by the Chinese, and the other ones came from Polynesia, for instance. But all of those constellations are now recognized by everyone. So there were some that come from antiquity, but there are others that were defined in modern times. Does that satisfy you? Okay, great.
Well,
Go ahead.
early in your presentation, you were talking about how the Christian humanists
Right.
were trying to reevaluate Christianity history in terms of nature-oriented focus, but I'm not maybe saying it right, but did that also encompass their thoughts about who Jesus was? Like, do they say maybe he wasn't divine, maybe he was just an important individual in Christianity, but not a divine being? Is it?
That's going to be more like part 2 of my talk. I'll get a little bit more into that. But the question of like transubstantiation, for instance, which is something Catholics firmly believe, that was not always believed by the church, and they fought wars over that. The church split into pieces, at some point because of someone would come up with some proposal, Jesus was born of a virgin, and you'd have a shitload of people over there saying no, he wasn't, and they fought a war, and then eventually the Catholic Church settled on something. But during the time of the after antiquity, after the Middle Ages, when sort of the Enlightenment started up, the church was powerful at that time. It had a lot, it had a lot of influence over everything going on in Western Europe, but they weren't as powerful as they wanted to be. So they had to find ways of getting more people on board with the idea of Christianity. And one of the ways they thought to do that is they looked at these humanists, these people who were going around collecting old Greek manuscripts and going to libraries and reading information. They thought these people could be useful. The usefulness they could play is that they could create more of a firm foundation for belief in Christianity. And so the church actually supported financially and otherwise a lot of these humanist efforts, thinking that the result of their work would be more important information that could be used to turn more people into Christianity. And that worked for a while. Like for instance, Tycho Brahe, the astronomer, firm believer in the geocentric system, was supported by the church, and he was also supported by the Danish king, who essentially gave the man an island to set up his own observatory. But all of the information he collected, he funneled directly to the church. But he knew who paid his bills. So there's a symbiotic relationship here between early Christianity and the work of the early humanists. They saw some value in it. Go ahead.
Were there any great astronomers in Central America, like the Aztecs or the Mayans?
Well, there's certainly some contributions from that era, certainly. I don't know them by name yet. Those are,
In Rome?
yeah, there are. Just come to part two. That's gonna, so sometime in there, we will see it. Go ahead.
When you were describing the beliefs about the sun being Helios, the sun god,
Right.
did they really think that that sun, that burning thing up there, is the god? Or did they think that was a plaything of Helios who, like his top that he spun around?
The Greeks with their someone else please help me out with this because I'm not as knowledgeable as I should be on this subject. The Greeks kind of assigned real personality traits to their gods, like Apollo and all of the gods that they worshipped had well-defined personalities. I think they thought of the sun as a real person or a being, something
So it
similar to
wasn't a
them.
toy, that was the god.
Right. And that was the kind of thing that got Anaxagoras in trouble because he suggested that the god isn't a god like you and I would recognize at all. It's just a burning rock.
Maybe he was the first humanist when you think about it.
Maybe,
First
maybe.
secular humanist, maybe. I have no authority. I know nothing about this, but I can see that, you see all the stars and they're all fixed. They're always doing the same thing all the time. Then the planets kind of do their own thing.
Yeah.
I wouldn't be too much of a stretch to me to think, oh, it's really just a person up there.
Well, except that all the different, when you hear about the different things that gods did to each other and,
Right.
Swans, having sex with Zeus and all that, or Zeus having sex with somebody else, a swan. Those aren't things that a fiery ball in the sky can do. That requires some other manifestation.
Yeah, I tried to look for more information on just exactly what it was about Anaxagoras' statement. Like I want to look for, maybe there was some description of his trial or the accusations that were made or something like that. But I think when Anaxagoras basically said the sun was anything other than Helios, that's what got him in trouble. At least that's the gist of what I've been able to find out. Any other questions? All right. Well, thank you very much for attending. I hope this was worth your while.